Hello and welcome to 5-Minute Math. Today we are looking at activities for Algebra 1 Standard A.8A. This is off a blog post on my site, 5minutemath.net. I will make sure to put the link to this blog post in the video description. So let's look at A.8A. We are solving quadratic equations with factoring, taking square roots, completing the square, and applying the quadratic formula. Here are some teaching videos for students that might need a little bit of rehearsal with those different strategies for solving quadratic equations. And this is how we did on the 2023 STAR test. You'll notice that we only got 30% correct, and you see all these radicals as our answer options here, so that might have messed some of our kids up. This video here is just an explanation as to how to solve that particular problem and just a bit of a framework for these activities. I'm wanting to make these activities active, playful, engaging, meaningful, so that students are having fun and that they're hands-on, minds-on, rather than just boring worksheets. So there is a method to the madness behind these activities. But let's get straight to the activities. The first activity that we can look at is going to be called Countdown. And so what you're wanting to do here is you're wanting to put students into pairs or groups of 4, have some type of timer on the board or on the screen, and then have a quadratic equation for the students to solve. And then within the time limit, they are trying to find one, possibly both, solutions to that quadratic equation. And what you want them to do, and I've got an example here, is 1 point for each solution if they use the quadratic formula, 1 point for each solution if they complete the square. So the only difference here is that you're just adding a little bit of pressure with the timer and putting the points up there, and they can either work simultaneously on each strategy, divide and conquer, or they can pair up and they could both work on one strategy and then they could both work on the other one. And what you could do is you can rotate partners, keep track over a week, and see which student ends up having the most points. Now, what makes this fun is if you want to add some extra point modifiers, and this will be something that comes up as students are starting to kind of get the hang of this. So let's look at some of our extra point modifiers. So these would be optional, and this would be chosen by the team before starting the quadratic equation. So after they see the quadratic equation, they can have an extra point modifier to where they get 3 extra points. If they get all 4 standard points, that means both solutions using the quadratic formula, both solutions using completing the square, but they get 0 points if they don't get it. So they're going to end up either with 7 points or 0 points because it's all or nothing. You can get an extra 2 points here for ain't no help. That means the teammates cannot help each other. And they must earn at least 2 standard points, so they need to divide and conquer. The blind nil means that they choose at least 1 extra point modifier before seeing the quadratic equation. 2 points would be speedy. They have 25% less time. And then this is just a random one, 5 extra points if one teammate can only write with his or her offhand. So you can add as many of those as you want to. And just make it a little bit interesting. Just gamify it a little bit. Have students suggest their own extra point modifiers. Have students provide their own quadratic expressions to be used in Countdown. In order to do that, though, they would need to have the solution shown in both the quadratic formula and by completing the square. And if you teach multiple periods of Algebra 1, you can have classes compete against each other. Make sure you've got the same number of teams per class period, and then just count up the total number of points that class period has and compare that with another class, and you get a little bit of a rivalry there. So that's one activity. Our second activity is called Hidden Gallery Walk. And so what we want here is we want students using all 4 of these strategies, completing the square, quadratic formula, plus square roots and factoring, which don't show up on STAR nearly as much, but they're obviously important to learn as well. So you want to divide the class into 4 groups, 1 for each type of strategy, have masking tape, blank paper, and any exemplar scaffolds you might want, and a problem to solve. So here are some samples. I've got those right here. Those are the materials and the steps needed here. And what I have here are simply some examples if you would want them worked out. So the factoring one's obviously going to be pretty easy. Students can solve that. If we're going to take the square roots, it's already in that form right there. So here in bold are kind of the steps that I'm working on for each layer. Then you've got completing the square, then you've got quadratic formula. So that's just for your reference. What you want here is that students spend blank amount of minutes you decide at their station solving the problem. When complete, they tape their paper with a solution to the wall at their station, and they make sure that the solution is hidden, right? So it's not visible. As long as they're not the first group there, once they've taped their solution, then they can take some other solutions off from other students and then compare their answers and then return those to the wall. So that's kind of a self-check right there, is that they move on to the next station after they've checked a few solutions. Now, some variations here. If they're stuck, you can make this a visible gallery walk. Have students from the previous group tape their solutions to the wall, but have it with the solutions facing out, and that could be a reference as needed. Instead of having a timer for each station, because obviously the factoring station will not take nearly as long as some of the other ones, you can make this just a on your own station activity. They rotate through all 4 stations at their own pace in any order, and they have to solve using the noted strategy and then tape their answers to the wall. Before moving on, have them check their work with at least 3 other answers for verification, so people can kind of do it at their own pace. If you want, you can add a 5th station that uses any strategy. It's kind of a choose your own strategy here. And then what you could do is you could divide the wall behind that in that station into 4 sections, one for each strategy, and have them tape their solution as to the one they chose, and that give you kind of an idea as to which strategies the students prefer. Then obviously you can use some online whiteboard apps, Jamboard, Lucid Spark, FigJam. You could do this all digitally rather than with paper and pencil. Our 3rd strategy is called quadratic relay race. So students will solve quadratic equations using a variety of methods. You're going to put students in equal teams. You're going to have a series of quadratic equations on index cards, and I've got some index cards right here. And you notice that at the top here, we're going to have a suggested strategy. So most of them will be quadratic formula or completing the square. There are a few that have factoring or square root. And what you want is that suggested strategy. And it's going to be just a basic relay race. So the first person goes, grabs a card, has to solve the quadratic equation on paper, personal whiteboard, using that suggested strategy, whether it's quadratic formula, completing the square. If the student prefers another strategy, they can do so, but they have to walk 1 circuit around the room. So that just adds a layer of complexity there. If they're stuck and they need assistance, they could get a teammate to come help them, but that teammate has to walk 2 circuits around the room, and then they can help. And then once that problem is solved, the next person in line, they tag them, they grab the card, and they do the next one. So it's going to be a real, high-paced quadratic relay race. So some variations there. Instead of randomly choosing teams, you're going to have team captains choose the first students in each team. I would not recommend going all the way to the end because no one likes to be picked last. So have each captain pick 1 or 2, and then you randomly assign the unpicked half of the class. You can add more circuits around the room for any use of alternative strategy or calling on a friend for help. I just chose 1 circuit or 2 circuit, just arbitrarily. You can have wildcards in the mix, so these quadratic equations can be solved using any strategy. And if the class is struggling with using a specific strategy, like they're just not really good with completing the square, make all the cards suggest that strategy. And all of these are Google Docs. Feel free to just make a copy, right? You go File, make a copy, and then you can personalize these as you want. So our next strategy is called Spot the Mistake. What we want here is we want some solved quadratic equations with a mistake. Now, I've got some mistakes highlighted here. Obviously, if you're using this with students, you would not show the highlight, right? So look at this first example here. We've got x minus 3 and x plus 9, and rather than solving for moving the 3 to the other side, I just did a minus 3 and a plus 9, right? So I didn't reverse the signs there. On this one right here, you notice I divided this side by 3, but I didn't divide that 75 by 3. So that ended up changing this and adding that radical of 3 that I didn't need. In this one right here, rather than taking half of b for completing the square and then squaring it, I just took half of b. So this should be a plus 4, but I ended up just doing a plus 2, and that changes everything. And then finally, on this one right here, I used the quadratic equation, but rather than negative b, I just did a positive b, or positive 1, and that obviously changes everything here and gives me different solutions. So the idea here is that you're going to put one mistake in there, Have students work in partners or small groups with everything worked out, and they're going to try to spot the mistake. When they spot the mistake, have them come up to the front, give the other groups 30, 45 seconds, try to spot the mistake. Then that first group is going to explain what the mistake is and how they know. Then you're going to give groups a minute or two to actually solve it correctly, and then a group can come up and volunteer to show, okay, this is how it should have been solved. So, some variations. Instead of putting a time limit on it, have the example with a mistake shared at the beginning of class, have them work on it at their own pace throughout the class as they get done with work, and then you go over the answer at the end of class. After a group shares how to solve the equation correctly, have another group to share how they solved it using a different strategy, right? So one group solved it with completing the square. Did anyone do it by using the quadratic formula? If you really want to mess with kids' brains, every once in a while share a worked example with no mistakes and just see if they can realize, hey, this one actually doesn't have any mistakes. And then students can create their own examples, but they need to complete it with highlights and submit them for future use. Our final strategy here, activity that we could use to help with A.8A, is going to be calculate, draw, check. We are going to need some graph paper, and you're going to give students a quadratic equation to solve, ensuring that these solutions are going to be integers rather than radicals. So here's the example, x squared plus 4x minus 12. So what you want them to do is find the solutions, right? So the solutions are going to be 2 and negative 6. You want them to find the intercept, the y-intercept, by substituting in 0 for x. So that's going to be a minus 12. And they're going to find the axis of symmetry, right? So that's going to be the x equals negative b over 2a. So your x coordinate for the vertex is going to be negative 2. Plug that back in to find what the y coordinate is going to be, and that's going to be a negative 2, negative 16 for the vertex, okay? And so once they find the vertex, the y-intercept, and any solutions, have them actually draw a picture of that graph on the graph paper. And they should be able to do a fairly good approximation if they have the y-intercept, the solutions, and the vertex. And then you can either show the correct answer on the interactive whiteboard or allow students to check their work using graph calculator or maybe Desmos. And so, for example, this is what it would look like here. For that particular one, this is the example that I might have on Desmos. And if they drew something that looks like this, they would know they got it right. It's just a self-check activity. So, variations. You can pair students up and have one student find the solutions, the other student find the vertex. You could divide the class into groups and give each group a different equation to graph, and then graph each equation and print them out. So you would print out each visualization like you would here, and then when they've calculated their equation and drawn a graph, then they have to come up to the front, and you might have 8, 10 different pictures printed out of these graphs. They have to find the correct one from the 8 or 10 examples that you have up there. So there's just that little extra layer of they need to match theirs with the one that you actually printed up from Desmos or whatever. You can add equations whose solutions are radicals. Obviously, that's going to involve a little bit more of estimation when they're drawing it. And you could turn this easily into a memory match game if you wanted to have this as kind of a self-check. They can have the equation itself, the graph of the equation, the solutions, and the vertex. Those could be the 4 different components, and they can match pairs, or they can try to get all 4 as a book.